Hey guys, hope you're doing well. Last week we went over sine and cosine graphs. Today we're going to be looking at the next section on page 330, 4.6. So I'll give you a chance to get there. Pause the video if you need time. So we're going to be looking strictly at tangent functions today. Tomorrow I'll be uploading a video that will show cotangent graphs. So this is tangent. Okay, I'm going to show you how the book gets this picture, and this is the parent function of tangent. Once you can get the parent function of tangent, you can get any function of tangent. But you really need to know how to get the tangent and understand where it comes from. So the first thing to remind you is that tangent is equal to sine over cosine. Which another way to look at it is y over x, right? Okay, so now when we look at our unit circle, sorry, I'm not the best at drawing circles, we know that y over x is not defined everywhere on the circle, okay? So for example, here at 0, 1, pi over 2, once we put 0, 1 here, right? So like for example, 0, 1, we put y over x. We don't have an answer here. This is undefined. So this is not going to help us get points on the graph, but it is going to help us to get our vertical asymptotes. As you could see from the picture in the book and the picture that I shared here on this document, you could see those red dashed lines. Those are your vertical asymptotes. Because at those places, okay, tangent is not defined. So let's now talk about where to get our defined values. Now, many other parts of your circle have defined values of tangent, but we want to get the easiest points, okay? So where would those be? Well, right here at 0, okay, at 0, that's 0.10. So at 0, we have y over x, and that's 0. Okay, so that's definitely a number we want to use, 0. Where else is tangent easy? Well, definitely right here. Okay, at pi over 4, we know that we have square root of 2 over 2, square root of 2 over 2. And why is that easy? Because when we divide anything by itself, that automatically gives us 1. So right here at pi over 4, when we divide y over x, that's going to give us 1. And that is definitely easy value. Now, where else can we get an easy value? Right here. Okay, at negative pi over 4. Really, at any pi over 4, right, we're going to have an easy answer. But I'm showing you how to get the one that the book has right there. Okay, so between negative pi over 2 and pi over 2, which are right here and here, okay, I'm showing you how to get that graph, okay? So that at negative pi over 4, we have square root of 2 over 2, negative square root of 2 over 2. So when we divide that, that's negative 1. And again, at every time we reach an over 4 and over 4, we're either going to have values of 1 or negative 1. So that's why anything over 4 is going to be our key points, okay? And it's just going to keep repeating, okay? So now let's look at the period. If you look at the book, the first thing they tell you is that the period is pi. So let me just actually start fresh here. Okay, so again, y equals tangent of x. So for every time we have a tangent function, we have to define our domain, our period, our domain, our range, and our vertical asymptote. Okay, our period of our tangent is pi. Okay, why is it pi? Because after pi, we cycle again and we get the same values for y. Where sine and cosine were 2 pi, because every time we pass 2 pi, we're going to cycle the same answers. Okay, now For sine and cosine, our domain was all real numbers. This time, for tangent and cotangent, our range is all real numbers. We write it also as interval notation, negative infinity to positive infinity, okay? Now, the hardest part about tangent and cotangent are your domain and your vertical asymptote, okay? But they go together. So once you figure one out, you pretty much will know how to get the other, okay? So domain, we said this earlier. What x values are not included in the domain of tangent? Well, every time we reach a pi over 2, okay? So how do we write that? X can equal pi over 2 plus n pi, okay? So it's always going to be pi over 2 plus n pi, depending on your period, okay? Now, once you figure that out, your vertical asymptote is the same as your domain, except instead of writing not equals, we're going to write equals. So x equals pi over 2 plus n pi, okay? All right, so now let's talk about the key points and how we would put this all together into a graph. So once you have this, okay, the next step is making a table. So make your table of values. And again, your key points, which by the way is only 3 points, whereas sine and cosine had the 4 points, actually 5 points. So for tangent, we're going to have negative pi over 4, 0, and pi over 4. Okay, negative pi over 4 is going to give us negative 1, 0 is going to give us 0, and pi over 4 is going to give us 1. Okay, now let's put this together into a graph. So let's draw in. Okay, so I'm going to space it out by here. Let's talk about the first a period of 1 pi, right? Okay, so 1 pi from here to here. So let's say here negative pi over 4 and pi over 4. Okay, so negative pi over 4, 0, 0, negative pi over 4, negative 1. I'm going to have to skip by 2 here just so it's a little clear. Pi over 4, 1. Okay. And I keep getting texts, of course, while I'm making this video. I don't know if you've noticed. And here we go. That's not a great picture. It should be a little bit more curved. Let me try again. A little bit better here. Okay, that's a little bit better. Okay, so here's 1 pi. Here's our period. Now after that, okay, here are our asymptotes. So here let's say that this is pi over 2. Here let's say this is negative pi over 2. Here is 1 period. Now after this, let's draw in another vertical asymptote. So here, right, we have 3 pi over 2. Here is another vertical asymptote. And we could say the same thing over here. This would be negative 3 pi over 2. So what we're going to do is we're going to make a few more, and we're just going to basically make the same sketch. We don't need to define what these points are. Just sketch the same thing here, like that. Just make it look the same. And voila, you've got your parent function of tan x. Okay? So once you just do 3 points, you can just sketch the rest. Okay? Now I'm going to do one more example with you, but I'm going to throw in some extra numbers. So let's do, let's say we have y equals 3 tan of 2x. Okay, so again, identify your period, domain, range, and vertical asymptote. And again, period and range is the easy part. Finding domain and vertical asymptote just requires a little bit more work, but it's not too difficult. So your period is generally pi, but whatever you have, whatever numbers in front here, you would divide it. Okay, so we would have here our period pi over 2, just like we did for sine and cosine graphs. All right, our range is always going to be all real numbers. So those two are the easy things to fill in. Now your domain and your vertical asymptote. So what are our vertical asymptotes are at our pi's over 2's, okay? So we usually have a vertical asymptote at negative pi over 2 and at pi over 2. But because we divided our period by 2, we're also going to divide our vertical asymptotes by 2, and that's going to give us our new vertical asymptotes. So hopefully you could figure that out. That would be at negative pi over 4 and pi over 4. So at our pi over 4's now, that's where we're going to have vertical asymptotes. So how do we write that? We would say x equals, so these are equations. So you would say x equals pi over 4 plus n, and now it's going to be pi over 2 because we have a new period. And again, whatever your vertical asymptote is, you do the same for domain, except you just write with a not equals. That's all. So x cannot equal pi over 4 plus n pi over 2. Okay? Now we make a table. So normally what are our, for our table, we have our key points. Our key points are usually negative pi over 4, 0, and pi over 4. But again, look what we keep doing. We keep dividing by 2, so that's what you have to do to the key points as well. Okay, and that's going to give you your new key points. So we're going to have negative pi over 8, 0, and pi over 8. All right, so now let's make this into a table. And also keep in mind that we have a 3 in front. Okay, so what does 3 do? 3 gets multiplied to our y values. Got it? Okay, so let's make our table. So we already know our x's here. All right. And now for our y values, like I said, it would normally be negative 1, 0, 1. But because we have that 3, now it's going to say negative 3, 0, and positive 3. All right. Now we're ready to make our graph. So the first thing I like to do when I make my graph is plot these points, okay? So this time it's a little bit smaller, right? So I'll do here, here. So we have 0, 0 right there. At negative pi over 8, negative 3, we are here. And at pi over 8, 3, we are here. Okay, so let's draw that in. And now at our pi over 4, so let's say that's here, we're going to have a vertical asymptote, okay? And right here, at negative pi over 4, we have a vertical asymptote. And as you can see here, the period is not pi anymore, it's pi over 2. And after this, it just keeps repeating. So we're going to do the same thing. We're going to just draw in and sketch another vertical asymptote. That would be, since we're going by pi's over 4 now, this would be 3 pi over 4. And we would have negative 3 pi over 4. Okay, and we're going to plot, we're going to just sketch this to make it look like the middle guy. And voila! Here's our function y equals 3, tan of 2x. Okay. Now, the problems could get a little bit more complicated if there is a number after x, okay, as we've seen from the last section. But again, we're virtually learning, so we don't want to do problems too complicated. If we were in the classroom and had more time, then yes. But for now, we're just going to keep it basic, although this is really not basic. This is pretty complicated things, complicated stuff. So again, hopefully you understood this. Tomorrow I will go over cotangent with you, and hopefully this gives you a good idea of what to do. I'll talk to you guys soon. Take care. Bye.